Oh, here we go. Let's look at number 7. This is 5.3 from yesterday. This is part 2. We have 3 more examples to do, and then you guys can have the rest of the class period to work. The way that you approach these problems, guys, first of all, everything is going to be over the interval of 0 to 2 pi, so you don't have to worry about that. But when you approach these problems, you need to first look at what you have. Okay? If you have all the same trig function, that's easy. Get it on the same side and just solve. If you have something that's squared and something that's not, but it's the same trig function, get it on one side and solve. If you have something that's squared and something that's not, but they're not the same trig function, then you have to do a little conversion and then get it on the same side, all right? This is a different type of problem from yesterday. The reason that this is different is because you have 2 different trig functions. You have 2 different trig functions, but neither of them are squared. You cannot look at your identities and say, okay, I'm going to change sine into cosine or cosine into sine. You have to have a Pythagorean identity to when we can kind of change stuff around. So when you start off with a problem like this, we haven't faced anything like this. We haven't seen anything like this. Nothing is squared. Do you guys agree with me that what you do to one side of an equation, you could do to the other? Yeah? Okay. So when all else fails, you don't have an identity to convert. If I move sine to the left-hand side, it's not going to help anything. Let's just square both sides. So when I square the left-hand side, this becomes cosine x plus 1 times cosine x plus 1. Agreed? On the right-hand side, I have sine squared x. Did that help me?
Yes.
Why?
Well, now you foil it.
Okay, I'm going to FOIL on the left-hand side. Perfect. So cosine squared x plus 2 cosine x's, right? Plus 1. All right. What can I do on the right-hand side? I can change sine squared to 1 minus cosine squared. Once you squared both sides, and the reason we can do this is because nothing is squared to begin with. So you have to create the identity. Once you realize that you have 2 different trig functions, and if you created an identity, then you could go to all in terms of the same one. You could do that, because as long as you do whatever you do to the one side, you do where? To the other. So now that we're all in terms of cosine, just move everything to one side and solve. So I'm going to subtract 1, and I'm going to add cosine squared. So when I do that, what is 1 cosine squared plus 1 cosine squared? 2 cosine squareds. Then I still have plus 2 cosine x. What happens to positive 1 and negative 1? They cancel. Equals, what happens over here? It all cancels. So now we just have an algebra factoring problem. What do they have in common here? 2 cosines. So I'm going to take out the 2 cosine x. And when I divide this by 2 cosine x, just x. And I divide this by 2 cosine x. What am I left with in the first term? Cosine x. This divided by itself is just plus 1. Now do we have 2 little pieces that we can set equal to 0 and solve? Yep. 2 cosine x equals 0. Cosine x plus 1 equals 0. Divide both sides by 2, right? I get cosine x equals 0. Over here on the right side, we're going to subtract 1. So I have cosine x equals negative 1. Are those my final answers? No. What do I need to do? Cosine is what? X values. So I need to look at the little circle, correct? To find all the x values that are 0. And then I have to look at the little circle and find all the x values that are negative 1. So we come up here. Where are all my x values? 0. So x equals pi over 2 and 3 pi over 2. Now I look to see where all my x values are negative 1. At pi. And there, ladies and gents, is your answer. So when you start off with 2 different trig functions, Neither of them are squared, just square both sides. Create the identity and then convert. All right, the last two are very simple. I'm going to rewrite this one because I don't like T's. I mean, I like the letter T, just not in algebra problems. All right, so we're going to go back and we're going to talk about solving this. We are going to get our trig function by itself, right? Do you see your trig function here? How is this one different from every single one that we've done so far? There's a 3 in front, all right? This is called a multiple angle problem. This is really, really simple. We're going to solve the exact same way, just the last step is different. So if I'm going to get cosine of x, cosine 3x by itself, what would we do? Add 1. Cosine 3x equals 1. Divide by 2. So you have cosine of 3x equals 1/2. All right, we're still solving the exact same way. What does cosine mean? X values. So we're going to look on the unit circle where my x values are 1/2. So where are they? 5 pi over 3 and pi over 3. Now, every problem we've done so far, I wrote x equals. How do you think I'm going to write this one? That's it. Yep. I'm going to write 3x equals pi over 3. And I'm going to write 3x equals 5 pi over 3. I want to know what just plain old x equals. So what do? Yeah, just divide by 3. If I divide by 3 over 1, that's the same as what? Timesing by 1/3. So here I get x equals pi over 9. Same thing here, divide by 3. So I'm going to times by 1/3. And I get x equals 5 pi over 9. With your multiple angle problems, you do everything exactly the same. Just the very last step, when you find whatever degree or radian measure it is in the unit circle, instead of saying x equals, you just say if it's 3x, 3x equals, and solve. If it's x over 5 equals, and solve. I'll do an example like that in a second just to show you. That's the only difference with the multiple angles. We good? All right, let's look at the last one. And then I'm going to talk just about a couple examples on your web assignment. Make sure you guys don't have any questions. All right, this problem says solve. So I have secant squared x minus 2 tangent x equals 4. Tell me what you notice about this problem. Okay, I have a secant squared, good. And I have a tangent. All right, so if I have secant squared, if I have something squared and something not, this is probably going to be what kind of a problem? Probably going to be a factoring problem. So let's just go ahead and move everything to one side. Secant squared x minus 2 tangent x minus 4 equals 0. I have a trig function squared, and I have one that's not. Now, if they were both the same, I would just go ahead and factor, right? Okay, well, they're not. So look at your identity sheet. Is there a relationship between secant squared and tangent? Remember, yesterday we talked about this. You want to convert to the one that's to the first power. Is there a relationship between secant squared and tangent? What? What is secant squared equal to? Look at your 1 plus tangent squared. So I'm going to change secant squared to 1 plus tangent squared. Am I allowed to do that? Absolutely. Then I have minus 2 tangent x minus 4 equals 0. Just a factoring problem, guys. What can you combine? The 1 and the negative 4, right? So this becomes tangent squared x minus 2 tangent of x minus 3 equals 0. Do you now have a basic factoring problem that's the same trig function? Yeah, what's going to go in the beginning of each parenthesis? Tan. Good. What are the factors of negative 3 that multiply to give me negative 3, but add to give me negative 2? Minus 3 plus 1. Good. My A term is 1, so I don't have to divide anything. So what do I do with those two parentheses? Set them equal to 0. Great. Perfect. So here I have tangent x equals 3, and here I have tangent x equals -1. Agreed? Okay. What is tangent? Y over x. So now we got to think a little bit. Where on the unit circle could I take the y value, put it over the x value, and get the whole number 3? We talked about knowing tangents yesterday, but if you didn't memorize them, no big deal. Is there anywhere on the unit circle that I could take a y value, put it over an x value, and get the whole number 3? No. Could I get square root of 3 over 3? Yes. Could I get the square root of 3? Yes. But will I get the whole number 3 anywhere on the unit circle? No. You'd have to have a calculator for that. You cross that out, you say no solution. There is a solution to it, but just not with what we're using because we're not using calculators. You'd have to hit tan 3 in your calculator and see if it gives you an answer or not. So now, I didn't put a unit circle on this problem for a reason. Just because I want you guys to think a little bit, all right? Tangent x equals -1. That means I took my y value, I put it over the x value, and I got -1. What do you know about an ordered pair that you'd have to put something over something and get a -1? 1 negative, 1 positive, right? But both the x and the y have to be what? To get 1 or -1? The same, right? What's the only ordered pair on the unit circle that's the same, x and y? X value and y value the same. Square root of 2 over 2. Yep. There is the ordered pair, square root of 2 over 2, square root of 2 over 2, right? That's the only ordered pair on the whole unit circle, plus or minus, that could give you a positive or -1. One of them has to be positive and one of them has to be negative in order to get, in order to get a -1, correct? Okay. So 1 negative, 1 negative here, whatever. Now you guys are going to have the unit circle. But I want you to understand, you don't have to, every time you see tangent, you don't have to go to the unit circle and be like, okay, put this over this, this over this, this over this. Think a little bit. Think about how you could get 1 when you divide two numbers. It's got to be the same numerical value. So where in the unit circle, guys, is positive, 1 positive and 1 negative root 2 over 2?
3 pi over 4.
Hold on a sec. 3 pi over 4.
Or 7 pi over 4.
Whoa, that is a funny looking 4. 3 pi over 4. And 7 pi over 4. Okay, good. Good. Celine.
Can it be either of them?
Yeah.
Like, for the negative, like either, you're saying either of them could be
Both of them. Yeah, both of those will give you a -1 answer.
Okay,
Yeah.
And then what do you do with the tangent x is equal to 3?
Just cross it out.
What is that considered?
It's no solution because it's not on the unit circle. You'd have to have a calculator. Yes, ma'am. Sure. All right, now a couple things I want to talk to you about with, all right, let's talk about some stuff just so if you guys have a question from WebAssign, I'm not answering the same question 100 times. For a multiple angle problem, all right, we had one that said 3x, right? 3x equals. What if it was like x over 4 equals something? Say it was, I'm just randomly making this up. But if you had x over 4, you would multiply by 4. Okay, I just want to make sure everybody's on. So like if I had one of my angles that I found was pi over 6, how would you get x by itself? You'd multiply both sides by 4, right? So this would become 4 pi over 6, which would become 2 pi over 3, right? So if you have a multiple angle that has a whole number in front of it, you're going to divide, which you're going to end up multiplying by a fraction. And then if you have a fraction to start off with, you're going to end up multiplying by a whole number. Okay, just to make sure we're good with that. All right, and I did see on WebAssign, a lot of people asked me the same question, so I'll show you guys. Just write this down. Say you have secant x equals 2. Okay, this was a lot of people's WebAssign number 3, something like that. Secant x equals 2. And you guys are like, wait, what? Okay, so let's think about this for a second. What is secant? 1 over cosine, right? Which is what value? So 1 over x. So you want to find a place on the unit circle that you take the x value, put it underneath the 1. You put 1 over the x, and you get the whole number 2. Right? Remember, the unit circle is a pattern, right? So I always start in the first quadrant and just see. If I take, we're looking at x values. If I take x here, and I say 1 over 0, is that going to give me 2? No, so it's not there. If I take the x and I say 1 over x, how would I simplify this? 1 times what? 2 over 1, which is what? 2. Is that my answer? Yes. That's how you would find the answer to a question like that. You would say, okay, wait, maybe it's this one. What if I say 1 over square root of 2 over 2? Well, this would be 1 times 2 over square root of 2, which would give me 2 over root 2. Then you'd rationalize, and you'd get 2 root 2 over 2, which gives me just the square root of 2. That's not what we're looking for. Whenever you have a basic, guys, this is super basic. You have a super basic equation. If I said cosine equals 1/2, you would find all the x values that equal 1/2. This just says secant equals 2. So you're thinking you're going to go to the unit circle and take 1 over all the x values and see what will give you this. So your answer here for this question would be where all the x values are positive 1/2. So it would be pi over 3. And where else is my x value positive 1/2? 5 pi over 3. Good. So don't get confused. If it was cotangent, how do you find cotangent? What's cotangent? X over y. So you'd have to think about, don't try to do a lot of stuff in your head because it's really, really easy to make mistakes when you do that. Write down as much as you can to help yourself out. Does that make sense? All right.